Right.
Okay, introduce ko na si Mark. Bale, Mark Kevin King is a guy who now works for himself and have partnerships with different companies. Born as an iOS developer but also does Android development and Rails API. Workaholic, yes. Trying hard to be a Sage developer. He has been developing mobile app for more than 4 years now. One proud work to be released soon in the market is the Krispy Kreme App. Yeah. Okay, pasok.
Yeah, okay. Our topic today will be, clean architecture, clean design pattern, clean code. So, first, we all write apps, right? We all write apps that works. Kahit ano tayo, no? Mga even beginners level, we write apps like Hello World. But once we add more features, things get complicated, right? And we all know, like, when we end up writing spaghetti code sometimes, just one feature, it will introduce a lot of bugs, a lot of errors. So, how will clean architecture solve this? Sorry, wala kasing presenter notes ko. So, question is like, when we develop apps, how long will it work? Will it work until version 1? Will it work until version 2? Sometimes we write codes that aren't really maintainable. So, yeah, and we end up having like a lot of code refactoring. Sometimes we spend like 7, 8 hours, 10 hours just to fix features. Some will tell me like it took them like 3 days to fix some simple stuff. So let me first tell you the Instagram story. Before Facebook bought it, Instagram was like developed, by some developers just for hobby. So they didn't have like this big whole-scale plan on how to build Instagram very well. So when Facebook bought them, we all know the feed features of Instagram, right? It's very complex. When they open the source code, it's really, really complex. Like adding a single feature takes more than a week, which doesn't make sense. Even they have this big whole team in Facebook. So remember, like adding a different type of feed shouldn't be very hard in the first place. So yeah, and they end up having this open source IGList kit to power up their feeds. So they end up writing these, core architectures that make sense and like, adding features like for advertisement, stories, videos. It's really that simple. Isn't that hard to do it now since they have a new core architectures that powers up their feed. So here, here's the data, and it will be feed to the adapter. Then it will be sectionized, and the end result is the cells will be attached to the collection views. So plain na simple lang siya, pero if you look, how the IG is kit, it's not just a simple collection view cells. Medyo complex talaga siya, but again, it works well, it works smooth, and adding a new type of feed is plain easy for them. So right now, did you notice how fast they add features compared before, right? So that's the Instagram story. And again, there are other features. Sabi natin, before was like ideally skip lang siya, feed lang siya. But again, there are tons of features in Instagram, and we want to know how they work very smoothly. So here's another example. Architecture stacks, ideally skip, and again, I don't work in Facebook, right? So again, there are a lot of it. So another one example is Heroku. So if you look at this is just a high-level architecture, right? Then if we go next, this is much more detailed architecture, right? It's very, very much complex. So that's the overall architecture. But the question is, how do we write clean architecture, and how should we benefit from it? So first, it's like, you know, building a house with a blueprint, and it's carefully planned. So if you don't plan very well, later on, if you encounter problems, sometimes going into the problem will be very hard. Um, Tagish na lang eh. Tagish. Tagish. Sige. Simple lang siya. Kung may foundation na kayo, then bubuksan nyo po ulit yung foundation. It is very hard to go to the center of it, like natayo nyo yung building tapos kakalkalin nyo pa. Mahirap talaga siya. Especially, we all know that refactoring is expensive, right? So we want to avoid that by having, clean architecture. So that is the primary benefit of it. And like I said, clean architecture, adding features should be relatively easy and portable, like adding APIs, adding views, view controller, or new screen, or new features. Dapat mabilis lang siya. So again, bug fixing shouldn't be very hard. So we all came from that, like when we fix something, a new bug appeared, right? We all came from that. So this is something we want to avoid by having a clean architecture. But again, having a clean architecture, there is always no right and no wrong. But again, there are best practices were made, and we should follow it. And it's proven, it's been effective. So how do we do it? So again, learn from examples. Again, we all go back to the basic, like class modeling, and different design patterns were introduced, right? Even, when we go to the college, all of these were introduced to us. But and it's been proven effective. So let's go to the class modeling. Pretty much the most basic things like inheritance. We should do it in the right way, but I've seen some examples from previous developers, and I'm just the guy who handled the next projects, and most of the time, inheritance weren't done correctly. Some view controllers, like they have primary controllers which has an API call, and they keep subclassing the view controllers just to have these APIs, which is wrong. And these are just example, and there's this case like a single checkout screen having 2,000 line of codes doesn't really much make sense, right? And if you look the whole concept of the UI kit, this is how they apply the class modeling subclass. So at the heart of Objective-C or Swift, we all inherit our classes from NS object. Then down below, another example is we have there's supposed to be a UI view here. Hindi na nakita. It's way below. Anyway, there's a UI view where UI text field, UI text view, label, button, all inherits it, which makes sense, right? So, let's write, our modeling class correctly. But this is just, typical example or the practice we can learn. Again, common pitfalls sa iOS, natin yan. Let's go to the example, like we have an animal view control. Most of the time we try to recycle our view controller, right? And what happens? We end up having many states. Example, add, edit, view are pretty much different, right? And the most closest similar is like add and edit, right? So the more state we have in a view controller, the harder to debug it, when something comes up. So again, best practice is to have them separate. We have the view animal controller, view controller, add animal, view control, edit animal, view controller. So, let's try to work, our class much more independent to each other. So, the more classes you have, actually, it's much way better. Okay, what happens if our controller has multiple states? Like I said before, more codes, harder to debug, state issue, and we end up having like a fat view controller. And the CBOP, our storyboard file, like when you adjust, that's supposed only to the view function, and you end up needing to adjust also the edit and adjust to make everything works. Okay. So what's a fat view controller? So fat view controller is typically you have a view controller like more than 400. I think the best threshold is 400. If you have more than 400 lines of code in your view controller, you should think about if I am doing it right or no. So also the basic is like the access modifiers. Remember, the access modifiers are important because it is how you architecture. So remember, codes, not all classes should access functions when it shouldn't. So we have again public, private, private, and internal. Internal is usually used in a module. So if you ship SDK, it's usually in internal. So unless you mark the classes private, that's the only way you can access. So here's a typical example. Let's say we're a human, right? And I need water. And of course, I'll go to the faucet and, just access the open function and I'll return a water. But again, as a consumer, I don't need to know how the pipe works or what are their function is, how how the water gets supplied from the water tank. I technically doesn't, as a human, I don't really need it. I just only need to interact objects that I need. So, as a human, let's say we have a human class, I'll call the faucet instance and only access the open. That's all. And everything is abstracted. So the more abstraction you have to the classes, it's much better because it simplifies everything. And yeah, we all know like at the heart of iOS development is MVC. So like this picture, we have this fat guy or the lean guy. So again, we all want to have this lean view controllers. So as much as we want, we try to reduce our codes so things are very manageable. So again, this is another example. Fat view controller and lean view controller. So we all have a view controller, and we tend to write like date functions inside the view controller. So here's a sample view controller that shows data. Sometimes we end up writing the login function in the view controller. We parse the JSON in the view controller, and we convert the dates in the view controller. But in reality, the view controller should only update views and read data. That's all. And having this kind of example should simplify a lot of stuff. So if we go to the next slide, this is how it should be done. So the view controller should only update views, and if we need like date functions, user functions that logs in, we separate them. So for the date conversion, we can have another class like date formatter just to convert the dates, and we like for logging in, we can create a user class that in reality they have an action for logging in. So what now we have a much lean view controller. So another design pattern is like MVVM. So what's MVVM? MVVM is like, having a middle layer that binds your object. So what happens, like your code will be much more testable. So we have this, view model. What will happen is this is your view controller, because we all know like storyboards, right? Is deeply coupled together with the view controller. So we will have a view model that where events like buttons, text fields, data, are just bind together with the view model. So like sample, if you type in the text field, your model class should be updated through view model, but this can only be achieved like using. It's easier to achieve with RX Swift, but that's a separate topic. And we go to Singleton. Singleton is like a design pattern. So it's a practice, that instantiate only one class. Sino dito napag-apply nito? Singleton patterns, yeah. And we found out it's proven like to be effective. And most of these examples, like, data manager, syncing with data, we only have one class that, does it all for us. And like another one is API service. We have like the only one API service to handle all the API transactions. Even the access token, the API manager should handle, and it only exists in one instance throughout the app. And we all know the very heart of iOS is the app delegate. So that's a singleton pattern, and the app delegate should only exist once throughout the life cycle of the view controller. So another third-party example that has clean architecture is the Moya framework. So basically, from sometimes I do this, like we have our app and we access to the Modifier or network layer directly. So what Moya will do is, so I never did try it, but it provides how it should be done correctly. So our app should only access Moya, but our app shouldn't have codes that relates to Alamofar or any internet protocol. So it's just a level of abstractions. And what does clean architecture does is, just to provide you a summary on how to do it. Always write code that makes sense. Make layer abstraction so your code can work, pretty much independently. And the more independent they do, the more testable they are. And always think, how to scale up in the near future. So if you don't think of ahead, sooner or later you will have problem. And we all do Scrum, right? And at the end of the Scrum, try to retrospect and have at least 2 hours of it. Think about what you've done. Did I do it correctly or not? Trust me, it will save up a lot of days in the future when the times come. Pretty much that's all.